I'll just skip wait prediction because I don't think it's that important. But I did want to say one or two words about critical word first and early restart. So critical word first, basic idea here is that you can express to the memory system which word is the most important word. And usually RAM arrays, the buses are oriented in a way that they'll actually allow, it takes multiple pumps or multiple cycles to transmit the data across the bus. And usually these arrays don't care, at least like main memory, like DRAM arrays, big things on your chassis or on your system server motherboard. They don't really care if they return the data in this order, 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, probably 7, sorry. Or if you return it in a different order. Because they just want to use the bus as much as possible. So what you can do is you can say, address 3 is the most important one. Please return that first. So what can happen is it'll return the data, and right here, address 3 comes back, and it comes back first always, because that's the address that we're trying to access for this load miss. And you can start the CPU executing again while the rest of the cache line is filling into the cache. So you've basically done a little bit of overlapping, but this doesn't help that much, because usually there's not that many, a cache line is not that long. So it might help you a little bit. So if it takes 8 cycles to fill the cache, you might save 7 cycles if you were going to the last, if you were trying to load the last word in the cache line. But if you were trying to, let's say, load the second line in the cache line, it only saves you 1 cycle. And there is some complexity in actually building critical word first systems. Early restart is another way to do this, which a little bit less hardware. Instead of having the memory system rotate the memory that it returns back to you, it still returns the memory in the canonical order. But we just wait until, let's say, we want to address 3 here, it comes back, and then we restart there. So you can see there's a little bit of time here, which we can overlap the fill in with executing in the CPU again. In the canonical case, if we don't have early restart, what's going to happen is we have to wait for the entire cache line to come in, and then we can restart. So we lose these cycles there. We don't get that overlap. OK, let's stop here for today. And I'm going to remove the wait prediction stuff from material we're talking about, because this is not that important.